Computing research is all about systematically investigating problems and developing solutions within the field of computing. Whether it's creating a new software tool, improving an existing algorithm, or solving a complex computing issue, research allows us to better understand the technologies we use every day. Importantly, it's not just about writing code, it involves analyzing, evaluating, and theorizing how systems work and how they can be improved. Key takeaway: computing research is broad and covers many areas from theory to application. Landscape of computing theory, practice, application. This is the foundation of computing research and can be thought of as the spectrum of research-focused theory. This is where abstract thinking and fundamental principles come in. Think about the math and logic behind algorithms, formal methods, or artificial intelligence. Theoretical research is like building a blueprint before you start construction. It's foundational, but abstract. Practice. Here, we move to the development phase. It's about applying theoretical ideas to create functional systems, like software development. For example, you could develop a software tool using principles from software engineering. Application. This is where computing research meets real-world needs. How does the technology get used? What are the impacts on businesses, organizations, and society? It's more focused on practical implementation. For instance, consider how data is managed within organizations and how systems are used to optimize business operations. Think about it this way: theory is the why, practice is the how, and application is the what. Together, they form the full cycle of computing research. What is computing research? Computing research is a structured and goal-oriented process. It always starts with a specific research question or problem, which has a clear start and end. For example, a research project might ask, how can we improve the speed of data processing in cloud systems? That's a clear goal. The researcher then goes through existing literature, tests hypotheses, develops solutions, and finally documents findings. Pro tip: computing research isn't just academic. Many innovations in software, hardware, AI, and data science come from research labs in companies like Google or Microsoft. Research bridges the gap between academic theory and real-world application. I bet you didn't know how diverse IT education can be. The field of information technology, IT, can be broken into three broad disciplines, each with its own focus: computer science, CS. Think of this as the hard science of computing. It deals with understanding how computing systems work at a fundamental level, designing complex software, studying algorithms, and exploring computational theory. Information technology, IT. This field is more about the application of technology. IT professionals focus on implementing and maintaining the infrastructure that companies need to function, such as networks and databases. Information systems, IS, is the middle ground, focusing on how technology integrates with business processes. It's about making sure systems align with organizational goals, requiring a solid understanding of both tech and management. Why it matters. Understanding the differences is important when choosing a career path or research focus. For example, if you like working with algorithms and theory, you might lean towards computer science. If you prefer working on practical tech solutions for businesses, information systems might be more your speed. What is research? At its core, research is about discovering new knowledge or building on existing knowledge to answer specific questions. The important features of good research include generalizable. Your findings should apply beyond just one situation. For example, if you develop a faster algorithm for sorting data, it should work across different data sets. Repeatable. Another researcher should be able to follow your methods and get similar results. This is key for validating findings. Based on existing work, you don't reinvent the wheel. Instead, research builds on the findings of others, expanding the field incrementally. Research is not done in isolation, it's built on collaboration and the work of others. This allows progress to continue without wasting time on previously solved problems. Scientific method in computing research follows the same steps as in natural sciences. Ask a question, for example, how can we improve encryption for online banking? Do background research. What encryption methods already exist? What are their limitations? Form a hypothesis like using quantum computing could increase encryption security. Test the hypothesis through experiments and data collection. Analyze the data to draw conclusions. Report the results in a paper, presentation, or report. Application. If you're doing a project-based computing research study, you might follow these steps to design, develop, and test a new mobile app or software tool. Types of computing research. This is a big one, so let's break it down. Research-based computing research thorough investigation into a specific area. For example, studying the evolution of machine learning algorithms over the last 10 years. Problem solving, developing new methods to tackle existing challenges. For instance, finding a more efficient way to compress data. Evaluation. This involves comparing two or more approaches to see which is better. A common example is comparing different programming languages or tools to solve the same problem. Project-based computing research, development. This could involve developing a new software tool, algorithm, or even hardware system. It's hands-on, and typically results in something tangible. Industry-based. This is focused on solving real-world problems within organizations. For example, developing a custom IT solution to optimize a company's supply chain. Suggested areas of computing research. Here's where things get exciting. These are just some of the cutting-edge fields where computing research can be applied. Mobile computing. This could involve improving mobile apps, creating new mobile systems, or enhancing device connectivity. AI and machine learning. A massive field with lots of research on how machines can learn from data and make intelligent decisions. Game development and graphics. Research here can focus on creating more immersive virtual environments or improving the efficiency of graphics rendering. Natural language processing, NLP. This involves teaching computers to understand human languages. Think about chatbots or speech-to-text systems. Each of these fields provides rich opportunities for research, whether you're interested in building software, improving algorithms, or exploring emerging tech like AI. Research agenda. The research agenda helps define areas of priority for future research. For example, the DOST, Department of Science and Technology, in the Philippines has identified areas like grid and cluster computing. How can we connect many computers together to act as one supercomputer? Open source and low-cost computing, making technology accessible and affordable for everyone. Internet and wireless technologies, researching ways to improve how devices connect and communicate. These priorities ensure that research efforts are focused on areas that can have a real impact on society, whether it's improving health, agriculture, or disaster management. Final thoughts. Why does this matter? Computing research isn't just about theory or writing code. It's about solving real-world problems, advancing technology, and making a difference in various industries. Whether you're interested in game development, AI, or network security, there's a place for you in this field. When you're studying or preparing for exams, focus on understanding the types of research and how they are applied. Think of real-world examples of how technology affects businesses, science, and everyday life. By learning the landscape of computing and focusing on practical applications, you'll not only ace your exams, but also be well prepared for a career in tech. Enjoy!